Okay, we are at lesson 4.4, and I just want to summarize everything we've done so far. We've been solving systems in lesson 4.1. We were graphing and estimating the solutions. 4.2, we used substitutions. This is when one of the variables in one of the equations has a coefficient of 1 or negative 1. Makes it pretty quick and easy. For 4.3, elimination. When at least one pair of like terms has the same or opposite coefficients. And then sometimes in elimination, you need to multiply the one of the terms or one of the equations by a number or to get them to be the same or opposite. I like them to be opposite and adding, but if they were the same, you could do the same method that we've been doing other than just subtracting all those like terms. But I've only been showing you the adding method, just so that you're aware of that. Okay, so now we're in lesson 4.4, which is solving special systems. So what we've been doing so far, all those three methods described this one solution where the lines will intersect, and we've identified that point. But what if the lines were parallel? They will never intersect, therefore they will never have a solution. Okay, there will be no solution. And then the idea that, if it is the same line, it is going to have infinitely many if it is the same line. So, like that little circle trick I did, don't know what I did. All right, so here we go. Here is an example, right? Looking at these though, I even wouldn't make you graph them because upon examination, y is equal to 3x plus 1, y is equal to 3x minus 5, same slope, they're parallel, no solution. So let's kind of use some common sense while we're doing this and see if we can't figure this out. Looking at the first one, they're already solved for y. So this is only going to work if they're in slope-intercept form, that you can do this examination method. But if they are in slope-intercept form and you notice that they have the same slope, we know there will be no solution. Why? Parallel lines, same slope. We didn't even need to graph those. Okay, so I won't even make you graph those if you can identify that. Big ideas might, but I won't. Okay, looking at this one, they are not both in slope-intercept form, but this is a quick fix for the second equation. So we get y is equal to negative 5x. Notice, negative 5x, same slope. Again, no solution. Okay, because parallel lines and same slope. That's the main thing, is being able to explain yourself. Okay, now let's do some logic here, right? We could easily subtract, we could rearrange this by subtracting 10. X minus 10 is equal to 2y, would be divided by 2. So we'd have a 1/2 for the coefficient here. Now we're subtracting 2 here and dividing by 3, so we're going to have a negative 2/3. So that's not the same slope and it's not the same line. So we are most definitely going to have one solution. So I'm going to go ahead and subtract the 2y on both sides. I'll rewrite it down here. So we have x minus 2y, and that's equal to a positive 10. Now we have the like terms under each other, and then I'll use elimination. Let me just go ahead and change the color here. I can multiply maybe the second one by a negative 2, right? And that'll give me a negative 2x plus 4y is equal to negative 20. I'm done with this. So my x's will eliminate. I will get 7y is equal to negative 21, dividing by 7, and y is equal to negative 3. Then I can go up here and solve for x. So negative 6 plus 10, x is equal to 4. So I have one solution, and it is 4, negative 3. And again, you still want to check to make sure that it is correct for both. I am ready to clear. And moving on. All right, so solve the system. Well, if it is already set up for elimination, which it is, we have opposite terms right here. Sometimes it's just as easy to go ahead and eliminate, right? You're going to have, 2x is equal to 0, so x equals 0, and if we have that, we have y equal to 3. So 0, 3 is our ordered pair. There was definitely one solution. Okay, for this one, let's go ahead and solve it. Let's see, we can easily make this to eliminate y by multiplying by a negative 2 and distributing. So we would get a negative 4x minus 2y and negative 10. We're done with this. So this is gone, so we get 0 is equal to negative 10. Yeah. Is 0 equal to negative 10? No. So that's a no solution. So had we put it in slope-intercept form, these must be parallel. They would have the same slope. And in slope-intercept form, they're actually y is equal to negative 2x plus 5, and y is equal to negative 2x. So if you want to take the time to put them in slope-intercept form, you can. Let's see. We could go ahead and eliminate if we multiply the top equation by 6. So let's do that, and we'll have 12x minus 24y is equal to 60. And then we get, this eliminates, and this eliminates. We get 0 equals 0, which is always true, and we call that infinitely many. Solutions. And why? They are the same line. They are the line y is equal to 1/2 x minus 5/2 if you were to solve them for slope-intercept form. Since they were both in standard form, that seemed like a rather lengthy task. This was pretty quick and easy. We got 0 equals 0. We could evaluate that. So again, remember, elimination is probably our quickest method, if at all possible, and we can then interpret what the meaning of the solution is. So understanding what that means. Okay, I'm getting ready to clear. I gotta go to this. All right, well, here we are, all ready for the vocabulary and concept check. Again, picking between 1 and 2, and identifying that, and then letting me know if you have any questions, and I will see you in class tomorrow. Have a great night.